In this video, we will discuss one method by which wavelength can be determined of a laser. You will need one laser, a diffraction grating with a known D or distance between slits, a whiteboard or other flat surface, and a meter stick. Identify common misconceptions of problems with the lab. First, a laser is passed through a diffraction grating, which has thousands of tiny slits that allow only certain light to pass through. Each of the beams passing through are of the same wavelength, and the spacing between them can be used to calculate the wavelength with the angle between the dispensed light.
It was like 7:15, and I was like okay with being late, and so it was fine with everything. And then there was this talk of some woman dropping off a kid or something. She was like, 25 minutes, and so I went around.
Think of the unit circle. When the angle is small enough, the hypotenuse and longer leg are about the same length. As such, tangent, opposite over adjacent, would be approximately the same as sine, which is opposite over hypotenuse. The interchangeable use of sine and tangent is called the small angle approximation. Knowing this, we can now use the distance between the diffraction grating and the first beam, which is in line with the laser, that we will call D1, and the distance between the first and second light beams, which we will call D2, to approximate the angle between the two of them. After performing several trials in which you alter the distance between the laser and whiteboard or other flat surface, graph the collected data to find the value of D2 over D1, which would be the slope of the line, and then take the tangent inverse of this value to find the angle. Some common problems and misconceptions. The 3 Ds. These can get a little confusing since there are so many of them, but D is the distance between the slits of the diffraction grating, and it's just plugged into the equation. D1 would be the distance between the whiteboard and the diffraction grating that you can measure using the meter stick, and then D2 is the distance between the two first-order maxima. It can get a little confusing when you plug them into the equation, but make sure to put D2 over D1.